Negative exponents will be a continuation of using the quotient rule with exponents and simplifying. One thing we have to go in with whenever we talk about negative exponents is the exponents must always be positive in our answer. So although we may be given negative exponents to start with, our goal is to make them positive values. So if I look at a to the negative m, the way I make that positive is by using the reciprocal. So I'm going to go 1 over a to the m. So by moving the exponent, the whole term, across the fraction bar, it makes it a positive exponent. That is our goal. So using that idea of reciprocals gives us a positive exponent. So what if I have 1 over a to the negative n, or maybe a negative exponent on the bottom? So what I'll do here is move it up, and that becomes a to the n. Therefore, we're giving us positive exponents. We have to be careful as we start to see more negatives show up and make sure we are simplifying correctly. When I look at something like negative 2 to the quantity of, or to the exponent of negative 2, the first thing I would take care of is that negative exponent, and I do that by taking the reciprocal. And it's important to identify that this is the reciprocal of that value. So it's still a negative 2 in parentheses, but now we have a positive exponent. From here, that's the same as saying negative 2 times negative 2, because you have 2 of them, which gives you a positive 1/4. Now when I go to the next one where it has no parentheses, and I take the negative exponent to make it positive, the 2 comes down to become positive, but the negative, because it's not attached to the 2, stays at the top. So now it's 2 squared on the bottom, with a negative 1 at the top, which gives us an answer of negative 1/4. So we're going to use that along with what we've just did with quotient rule in the previous section to start to simplify more expressions. So the first thing I want to look at here is I want to reorder the terms together. So I'm going to put 6 and then negative 3, x to the 8th, and x to the negative 7. So now that things are together, we can make sure we are going to multiply coefficients just like you would normally multiply two numbers. And then we want to use the product rule for exponents. So I'm going to get negative 18, then I have x to the 8th and x to the negative 7th. We have two approaches we could do here. So one option is to now go negative 18 x to the 8 plus negative 7. That is the product rule. The product rule tells us when we have like bases, we can add the exponents. And in doing that, we get negative 18x. Gives us our answer. It's a solution. Now sometimes we have issues with adding and subtracting negative numbers, and so I offer a different way. So what I would also say is you could take negative 18x to the 8th, which we're good with, and say, well, what if I wanted to get rid of the negative exponents? To do that, I could move the x to the 7th to the bottom. So now it's down here. From here, now I have 8 x's on the top, 7 on the bottom, and that's going to simplify to be negative 18x, because I have one more on top when it simplifies. Both gave me the same result. Both are correct. It's really a preference to how you want to simplify them. So now we move to a problem like this one. Again, I'm going to divide the coefficients. This is not quotient rule with coefficients. It's 32 over 8 gives me 4. Now I'm going to bring down the rest of it. So quotient rule from here tells us this. I could take a to the 5th over a to the negative 2 and write it as 5 minus negative 2, because in division we subtract it. Again, if we're not comfortable with adding and subtracting negatives, that could be a problem. But if we look at it still, 5 minus negative 2 is a plus. So that comes out to be a to the 7th. If I did b to the negative 3 over b to the 6th, that would be b to the negative 3 minus a positive 6, which becomes b to the negative 9th, which needs to be a b to the 9th on the bottom. If we did that, we could put that back together along with the 4 and get a 4a to the 7th, b to the 9th as an answer. And if you're comfortable with the quotient rule, that's the way you'd get to the solution. Here's another way we could look at it. I could take the negative exponents and move them across the fraction. So I'm going to simplify those first. So in doing so, I get 4a to the 5th, a squared, over b to the 6th, b to the 3rd. These then become 4a to the 7th, over b, forgot a number, that should be third, b to the 9th. Give us the same answers. We're still making sure we have positive exponents and still getting to the correct solutions, but it's just the way you want to go about simplifying it. So let's look at some more. Let's go to negative 24 x to the 5th over 3x to the negative 2. First thing I want to look at is the coefficients. I'm going to treat this as normal division. Negative 24 over 3 gives me a negative 8. Now, I want to make this negative 2 positive exponent, so I move that up to the top, and I have negative 8 x to the 5th x squared with nothing underneath, so I just put a 1 as a placeholder. Now, by using the product rule, I can put these together and get negative 8 x to the 7th. For this problem, I want to take care of the negative exponent first. So to do that, I'm going to take the reciprocal. So that's 4x to the 3rd, y to the 6th, with that quantity now squared. From here, I can take the 2 and apply it to each term. So 4 doesn't have an exponent, so that's going to become 4 squared. It's going to be x to the 3 times 2 and y to the 6 times 2, and that goes back to our power rule we saw earlier in a different section. So now to get our final answer, we're going to go 4 squared is 16. Remember, that's 4 times 4, not 4 times 2. X to the 6th, and then y to the 12th. When we look at something like x to the 3rd to the negative 3, and then the quantity negative 2y to the 5th to the 4th, we need to look at doing the power rule first. So here, x to the 3rd to the negative 3 becomes x to the negative 9th, which will then become 1 over x to the 9th. Negative 2y to the 5th to the 4th is going to be negative 2 to the 4th, y to the 5 times 4. So we have negative 2 to the 4th is going to be a positive solution because it's negative 2 times negative 2 times negative 2, negative 2, so that's 16. Y to the 20th. So I've taken care of my first term, my second term, I put them together, and my answer is 16y to the 20th over x to the 9th. Over here on the right side, I'm going to multiply the two top terms together first. I get 30a to the 12th, and then that's over a negative 12a to the 14th. Now I'm going to simplify my coefficients. 30 and negative 12, I can divide them both by 3, 2, but 6 would be the largest factor they have. So if I divide these both by 6, I get 5 over negative 2. Now, a to the 12th over a to the 14th, there's 2 more on the bottom, so I'm just going to put a 2 down there. I don't need to worry about a negative because my answer is 5 2a squared. I'll just move the negative up to write it like that. Moving down, we have product rule on these two terms first. Now, it may be tempting to go and say, well, 6 and 4 can reduce, 4 and negative 3, 6 and 5 there. You're not going to do that first because you have to do the power rule first, because in order of operations, exponents come before multiplication or division. So we're going to have negative 6 squared, x to the 4 times 2, y to the 6 times 2, negative 4 to the 3rd, x to the negative 3 times 3, and y to the 5 times 3. So if we clean that up, we got 36 x to the 8th over y to the 12th over negative 4 to the 3rd is going to be negative 64, x to the negative 9th, y to the 15th. So from here we have 3 parts to finish the problem: coefficients, x's, and y's. 36 and 64, I could divide them by 4 as I look at that. 36 divided by 4 is 9. 16 divided by 4 is negative 16. Now those are simplified down, can't do much else. X to the 8th and x to the negative 9th. What I'm going to do is move the negative 9 up to make it x to the 17th. Y to the 12th over y to the 15th is going to become y to the 3rd on the bottom because it has more of them on the bottom, and it simplifies to be 9 x to the 17th, negative 16 y to the 3rd. Last one we're going to do, I don't have any power rules here, so I'm just going to kind of simplify the top and the bottom. 6 times 3 gives me 18. B and b to the 5th gives me b to the 6th, and then c to the 5th with the 2 and 3. On the bottom I have 10 b to the 8th, c to the 8th. Now we simplify. 18 over 10, or 18 over 10, we divide both by 2, and that gives us 9 over 5. B to the 6th over B to the 8th, there are 2 extra on the bottom. C to the 5th over C to the 8th, there is 3 extra on the bottom. So I say 9 over 5b squared C to the 3rd.